Alright, so our next section on factoring is about factoring completely and solving equations by factoring. So your essential question is, how do I know when to factor or solve? And that's something that's commonly mistaken, factoring or solving. When do I know what to do? So first, let's take a look at some special patterns that we have in factoring. This will help us when we're factoring completely. So a perfect square trinomial. What that would mean is that when I factor it, it breaks down into a perfect square. So, for example, this is just a pattern. If I notice that the first number is a perfect square and the second number is a perfect square, then what I can do is I can take the square roots of these and I would get a and b, and whatever those values are, if the middle comes out to be 2 times a times b, then it is a perfect square trinomial. And so then when you factor it, it factors into two of the same thing. So it would be a plus b times a plus b, or you could write that as a plus b squared so that you don't have to write it twice. Now this is another pattern for factoring perfect square trinomials, except for we have a minus sign right here. So that's really the only difference. So then, if there's a minus sign there instead, then the only difference is it would factor into a minus b times a minus b, which could also be written as a minus b squared. Now this is just a pattern. You don't have to use this pattern. You could still use factoring by the AC method if you're more comfortable with that, but you will come up with the same answer. So this is kind of just like a shortcut if you can recognize it. So let's look at letter A. Letter A is a perfect square trinomial, but let's check to make sure. If I look at this value, 9x squared is a perfect square, and 16 is a perfect square. So if I take the square roots of those numbers, I would get that the value of A would be 3x, because that's the square root of 9x squared, and the value of B would be 4, because that is the value of the square root of 16. So the middle term should be equal to 2 times 3x times 4, which that would be 6x times 4, which is indeed 24x. So this is a perfect square trinomial. So now that I've identified that this is a perfect square trinomial, I can use my pattern up here to factor it. So that would be equal to a plus b, which would be 3x plus 4 times 3x plus 4. Now, since I wrote that twice, I could have just saved myself the trouble, and I also could have just written it like 3x plus 4 squared. So if I was to distribute this, 3x times 3x, that would be 9x squared. Then 3x times 4 would be 12x. And then 4 times 3x would be 12x. So 12x plus 12x would be 24x. And then 4 times 4 would give us 16. So it would come out to be that answer. So this is just a shortcut for factoring. Now, like I said, you do not have to use this shortcut. You could just use AC method. But sometimes it gets kind of tricky. If I look at this one, I can see that there are no greatest common factors that I can take out. And these are rather large numbers. So if I was to try to take 25 times 81, which would be 2025, and then I tried to find factors of 2025 that added to be 90, that might take me a while. So it's kind of easier to use the shortcut. So I notice that this is a perfect square and this is a perfect square. So the value of A would be the square root of 25n squared, which would be 5n. And the value of B would be the square root of 81, which is 9. So then if I check the middle term should be 2 times 5n times 9, which does equal 90n. So then I can tell that it's a perfect square trinomial, so I just use my pattern. So my pattern would be that I would take the value of a plus b times a plus b. So I would take 5n plus 9 times 5n plus 9. Or I could have also written it as 5n plus 9 squared. And if I check by double distribution, it will come out to be this answer. All right, so that's factoring perfect square trinomials. So that's just another way that you can do it. You do not have to use that way. You can also use AC method. All right, now let's talk about factoring completely. So when the directions ask for you to factor something completely, what that means is you just factor and keep factoring and factoring and factoring until there's nothing left that you can factor. It's all the way simplified. So these are just some steps that you can follow to make sure that you've factored completely. So you could write this down as a checklist to use when you're factoring. So you can factor a bunch of different ways. We've learned factoring by taking out the greatest common factor. We've learned factoring regular trinomials with a leading coefficient of 1. We've also learned AC method. So you have to keep factoring until the expression is fully simplified. So the first step, whenever you're factoring anything, it doesn't matter what, you always check to see if there's a greatest common factor. Okay, after you've checked that, then you should check to see if there's a special pattern, like a difference of squares or a perfect square trinomial like we just learned. Okay, after you've done those two things, or checked for those two things, if there's not a number in front of x squared, so it has a leading coefficient of 1, then you can just factor like normal. So you can find factors of the last term that add to be the middle term. Okay, after that, let's say there is a number in front of x squared. If there is a number in front of x squared other than 1, you have to use the AC method. And that would be all the steps that you could possibly do to factor something completely. Now, you won't use all of these steps every time. This is kind of just a checklist for you so you know that you factored completely. So let's take a look at some examples and try factoring completely here. So I have 2n squared plus 6n minus 8. So step 1 was check for a greatest common factor. So if we look, what would be the greatest common factor of these three terms? Well, I could divide all of these numbers by 2. And so I'm going to take out a 2, and then what would be left would be n squared plus 3n minus 4. Okay, step 2 was to check for a special pattern like difference of squares or a perfect square trinomial. Well, this is definitely not a difference of squares because there's 3 parts. And if I check for a perfect square trinomial, it could be, but I think this one would be easier to just try to factor like normal. So what are factors of negative 4 that add to be positive 3? So I could do 1 and 4 or 2 and 2. And if I do 1 and 4 and I make the 1 negative, then they would add to be a positive 3. So I would have 2 times n plus 4 times n minus 1. Because this negative 4 turned into, I wanted it to add to be 3. I had a positive 4 and a negative 1. So that's where I got my factors from. And then there's nothing else left that I could factor. These are all simplified as much as possible. So if I was to multiply this all back out, I should end up with 2n squared plus 6n minus 8. All right, let's try another example. 6x squared minus 216. So, step 1, check for a greatest common factor. So, let's see what I could divide all of these by. Well, 216 and 6 all divide by 6. So I can take out a 6 as my greatest common factor. And then if I divide that out, I would have left over x squared minus 36. Okay, the next step is to check for a special pattern like difference of squares or a perfect square trinomial. So if I look at this, I have 2 parts, and both of these are perfect squares, and I'm subtracting. So this would be a difference of squares. So there's 2 ways to factor a difference of squares. You can just take the square roots of the numbers and write your factors. And you remember that one factor must be positive and one factor must be negative so that the middle term cancels out. So you can think of it like that, or you can think of it as factors of negative 36 that add to be 0 since there's 0x in the middle. So I'm going to do the shortcut and just square root these. So I would get x plus 6 and x minus 6 because I want to have a positive and a negative. That way the middle part, the positive 6x and the negative 6x, will cancel out in the middle, so I just have this. And that would be factored completely because there's nothing else that I could simplify. Alright, moving on to solving equations by factoring. Okay, first I want to talk to you about the zero product property because this is why solving equations by factoring works. So when I solve an equation, you'll notice that in this example it is set equal to 0. So for this particular way of solving equations, your equation must always be set equal to 0. So if you have one that is not, you have to kind of manipulate it until you get one that's equal to 0. So then the zero product property, if you remember, that's just that saying that any number or quantity that's multiplied by 0 ends up equaling 0. So when we multiply two things, like if I was to have x plus 1 times x minus 2 equals 0, in order for this to equal 0, either this whole thing must equal 0 or this whole thing must equal 0. Because if this equals 0, then 0 times this will equal 0. And if this equals 0, then whatever this comes out to be times 0 will equal 0. So you can see that I can get two possible solutions for this. If I wanted this to equal 0, if I wanted x plus 1 to equal 0, then I would just subtract 1 from both sides, so x would equal negative 1. So if I plugged in negative 1 for x right now, negative 1 plus 1 would equal 0, and so 0 times this whole thing would equal 0. Now if I want this one to equal 0, if I have x minus 2 equals 0, then I would add 2 to both sides, so x would equal 2. So if I plugged in 2 for x here, 2 minus 2 would be 0, and then this times 0 would equal 0, so it works. So when you're solving by factoring, after you get your two factors, you have to set both parts, or however many parts you have 3 parts or 4 parts or whatever, equal to 0. That way you can find the multiple solutions that you can plug in for x so that this entire thing will equal 0. So let's go to example A. So they want us to solve by factoring. So what I'm going to do is I'm going to make sure my equation is set equal to 0. And then I'm going to factor the left side. So first we check for greatest common factor. There's not one there. Then we check for a special pattern like difference of squares or a perfect square trinomial. This one would be difference of squares. So I can take the square root of x squared and the square root of 25. So I would get x plus 5 and x minus 5 equals 0. Because remember, with the difference of squares, you have to have one factor that's positive and one factor that's negative. That way the middle cancels out. So then if I want to figure out what possibly x could be, then I would have to set x plus 5 equal to 0, and I would have to set x minus 5 equal to 0. Because if this equals 0, and I multiply it together, then the whole thing equals 0. And if this one equals 0, and I multiply these together, then the whole thing equals 0. So then I'm going to subtract 5, and so one of my solutions is going to be x equals negative 5. And on this side I'm going to add 5. So one of my solutions is x equals positive 5. So I have two solutions, x equals negative 5 or x equals positive 5. So let's check that really quick by plugging that in. If I plug in negative 5 for x, I would get negative 5 squared minus 25 equals 0. So negative 5 squared would be positive 25, minus 25 equals 0, so that checks out. Then if I plug in positive 5, 5 squared minus 25 is the same thing. It also equals 0, so that would be true. So that's why I can get two different answers. And they're not always opposites. That just is a coincidence for how this one worked out. So let's look at one more example, and then we'll be finished. Oh, actually two more, I'm sorry. So for part B, okay, we're going to solve by factoring. So we make sure our equation is set equal to 0, and then we have to check for a greatest common factor. So if we look, the greatest common factor of these two terms would be 8x, and then I would have left over, if I divide out, I would have 2x plus 1 equals 0. So in this part, the 8x isn't in parentheses, but you could put it in parentheses if you want to. If 8x equals 0, then 0 times this will equal 0. So I have to set 8x equal to 0 to find my first solution. And then if 2x plus 1, if this whole thing ends up equaling 0, then 8x times 0 would be 0. So I have to also set 2x plus 1 equal to 0. So then I would divide this one by 8, and I just still get x equals 0. And then on this one I would have to subtract 1, and I would get 2x equals negative 1, so I would divide by 2, so x equals negative 1/2. So my solutions are x equals 0 and x equals negative 1/2. And I could plug both of those in for x and check my answer, and it will equal 0. Alright, last one. 2x squared plus 9x plus 10 equals 0. Now, I made it easy for you, and on all of these I set this equal to 0. But let's say that this one, just for pretend, let's say that this one was equal to negative 20. If this was equal to negative 20, then I would have to add 20 to both sides before I could start, because it always has to equal 0. So just make sure you pay attention to that when you're working on these later. Okay? Alright, so we've got our equation equal to 0. And so then I check for a greatest common factor, and there's not one. And then I check for a special pattern, and there's not one. And so then I check to see if there's a number in front of x squared, and there is, and it's not a 1. So that means I have to use AC method to factor. So I would take A times C, which would be 2 times 10, which would be 20. And then I'm going to find factors of 20 that add to be the middle term, which would be 9. So I have 1 and 20, I have 2 and 10, and I have 4 and 5. So 4 plus 5 does equal 9, so those would be my two factors. Now remember, with AC method, you're going to rewrite the whole thing, and you're going to replace the 9x with the 4 and the 5. So we have 2x squared plus 4x plus 5x plus 10 equals 0. So then I can combine, then I want to factor by grouping. So if I take out the greatest common factor of this group, it would be 2x, and I would have left over x plus 2. And then I can take out a 2 from this group, so positive 2 taken out, and I would have left over x plus 2 equals 0. So then, since they both have x plus 2, I can take that out of both parts. So if I take that out of both parts, then I get x plus 2, and then I have 2x plus 2 equals 0. So to solve for x, then I need to set both parts equal to 0, because if this equals 0, then the whole thing is going to equal 0. Same thing. If this equals 0, the whole thing will equal 0. So I have two things. I have x plus 2 equals 0, and I have 2x plus 2 equals 0. So I would subtract 2 here, and I would get x equals negative 2. And then I would subtract 2 here, and so 2x equals negative 2, divide by 2, so x equals negative 1. So those would be my two solutions, negative 2 and negative 1. And I could check by plugging them back in. So then back to our essential question, how do I know when to factor or solve? Well, most of the time, you can just read the directions. It will say factor or solve by factoring, so you might have to do both. But the main thing is when you're solving, there's an equation. So if there's an equal sign, then you can solve. If there's not an equal sign, then you have to do something else, like factoring. Thank you.